Warahmatullahi wabarakatuh. Today I want to present you about water reticulation design project. Before that, I introduce myself. My name is Muhammad Makin bin Baznan 2019562711 in group 3B3. Okay, we go to the first slide. Okay, this is my first slide. First slide. This is a concept flow design. So before we to design the water reticulation, we need to know the concept flow design. Okay, we have 5 steps to know the concept flow design. First step is design part layout. Second step, flow scenario. Third, head balance method. Fourth, residual head. And lastly, design water tank. So we go to the first slide. So this is my first slide. Design part layout. So before we need to the design the water reticulation, we need to know the design part layout. We need to assume what the part layout that we use. Okay, this is my assume the part layout. First, we need to assume a diameter pipe equal to 0.15 meter. Second, we need to know what type of pipe we use. So my type pipe of we use is a high density polyethylene HDPE because in my knowledge, I know the HDPE is more stiffness, more strength, more toughness, and approximately and very important is more resistant to chemical and moisture than other type of pipe. So, in my knowledge, we know the roughness is C130 for the HDPA, and we need we need to know the design with what we use the number of loop. So my design loop is we use a 5 loop. I use a 5 loop. So this is my design. So we next go to the next slide. So this is my second step. So second step, we need to know a flow scenario. Before to know the flow scenario, we need to calculate water demand. So I have a step to calculate the water demand in each loop to know the Q, to know the flow rate. So after that, we calculate the peak flow and fire flow. Peak flow 2.5 times the total water demand to know the each peak flow in the loop, and fire flow is 1.5 fire release plus total water demand. So fire release we need to see the table in the that JKR brings, that JKR mentioned, the JKR procedure for the fire release plus the total water demand that we calculate. Okay, we go to the next slide. Okay, need to know the calculate head balance method. So this slide is known to the head balance method. So this is my example to calculate the head balance method. We need to do know head loss and the collection flow in the pipe that we assume, and to know the adjoining pipe. So this example my adjoining pipe. Okay, we move to the next slide. Okay, after we know the head balance method, we need to know the location for the water tank and to the house elevation, the water tank depth, water tank height and receiver. So this is calculation that we need to know the residual head. So we have the top water level, bottom water level, and the high supply level. So we go to the next slide. After we know the residual head, we need to know this is the last step that we need to know is the assume the water tank design. So we need to design the water tank for the total volume for the daily users in the each house. So we need to calculate the area tank. After we calculate the area tank, we need to know the information gathering for the D house, D area. So we need to know the total volume for daily users, service tank and land area for receiver, and lastly elevation level. After we calculate, we know the volume of the daily user for the water demand that we use. So my conclude for this design, we give in the we need to propose the water supply reservoir pipe network design flow, and we also given to make a design for receiver contribute water to the pipe with a connected 201 residential house that my project use. So we need to know flow rate, fire flow, peak flow, residual head, and last kali last water design. So that is my conclusion. That's all. Thank you.